Hi, this is Maggie. In this video we're going to solve a programming problem using recursion in Python. Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through chapter 7. If you don't have it, you can still learn a lot from this video. Open up idle and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something, or go back and watch again. You don't have to wait for me to tell you to pause. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the video. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started. The problem we're going to solve is from the Chapter 4 exercises from Problem Solving with Python. Chapter 4 is the looping chapter. Recursion and loops can often solve the same sorts of problems that require us to repeat some steps until some condition is met. I'm going to read you the problem from the chapter. Write a program to compute and print the hailstone sequence for a given number. The hailstone sequence is generated based on the following rule. If the number is divisible by 2, then divide the number by 2 and proceed with the result. If the number is not divisible by 2, then multiply the number by 3 and add 1 and proceed with the result. For example, for the number 16, the sequence is 16, 8, 4, 2, 1. For the number 9, the sequence is 9, 28, 14, 7, 22, 11, 34, 17, 52, 26, 13, 40, 20, 10, 5, 16, 8, 4, 2, 1. The Collatz conjecture is that the sequence will eventually reach the value 1. Ask the user for a positive integer and then loop, computing the hailstone sequence until you reach 1. Display the full sequence and the number of steps required to reach 1. Okay, so to start with the problem-solving steps, we need to define the problem. The problem is obviously pretty well defined because it's a problem from the back of a chapter. That means we know we're supposed to solve it with a Python program, and it's giving us some pretty clear instructions. Get an input from the user and follow the steps to produce the sequence and the number of steps. Let's make sure we understand the steps by going through the process for the two examples we're given. I'm going to leave this up on the screen and ask you to pause and follow the steps to compute the hailstone sequence for both 16 and 9, and then return. If you don't get the sequences shown here, then look at the process and see if you can figure out where you're going wrong. Pause now. Okay, how'd you do? Did you get the sequences we see here? Let's start with 16. 16 is divisible by 2, so we divide by 2. Then we proceed with the result, which means we're going to start over, but now with the result of 16 divided by 2, or 8. So again, divisible by 2. So we do that and proceed with 4. Again, divisible by 2, proceed with 2. Divisible by 2, and we get 1, we're done. Did we count the number of steps? We can count now that we're done. It was 4 steps. We divided by 2 4 times. Now, for 9, it's an odd number. So we don't divide by 2. We follow the other process, multiply by 3 and add 1. So we get 9 times 3 equals 27 plus 1 equals 28, and we proceed with the result. This time we can divide by 2 and we get 14. Divide by 2, we get 7, and now we have to multiply by 3 and add 1 and we get 22. Divide by 2, 11. Multiply by 3 and add 1, 34. Divide by 2, 17, etc. I won't get us all the way to 1 because hopefully you get the idea now if you weren't sure about it before. So there are only two options. Either a number is even or it's odd. So the algorithm is well defined. How do we know when we're done? How do we know whether a number is even or odd? take a moment to figure out the answer to those two questions. Pause the video and answer how we know when we're done and how we know whether a number is even or odd. Pause now. How do you do? The problem tells us when we're done, when we reach 1. And hopefully the Collatz conjecture is correct, otherwise we'll have an infinite loop, or infinite recursion in this case. We're going to trust that it is. And how do we know if a number is even or odd? If you didn't remember how to figure that out, I'll give you a hint. You use the mod operator. Do you remember now? If you divide a number by 2, you'll get a remainder of 0 if it's even, and a remainder of 1 if it's odd. So we can mod a number by 2, and if we get 0, the remainder, then it's even. If we get 1, we have to multiply by 3 and add 1. Okay, now we're supposed to identify and clearly express solutions. We've just talked a little bit there about parts of our solution algorithm, and we already know we're not going to use a loop, as in the original problem, but rather we'll use recursion. Briefly though, how do we know which to choose? Well, loops are usually more efficient than recursion. They take less memory and they run faster. Recursion can sometimes result in an algorithm that's easier to read if the problem has a naturally recursive form. And some languages require you to write everything recursively, so it's a good paradigm to be familiar with. We're going to write a recursive solution so we can exercise our recursion skills. So we've already chosen among the identified solutions. You can, of course, also solve this problem with a loop if you haven't already, and compare that to this solution. So let's get to implementation. Remember that with recursion, we're going to write a function. The function will have a parameter, which is the value we're working with. It might have more than one parameter, of course. The function will have an if statement in it, testing whether we're in a recursive case or if we've reached our base case. So it's going to look something like def hailstone, value is an integer, and then what are we going to return? I think we should probably return the entire hailstone sequence. I think that makes the most sense rather than printing it out as we go along and just keeping track of the number of steps. We have to print both at the end, and we can figure out the number of steps from the sequence by counting the values in it. So that sequence can be a string. For example, for the starting value of 16, the string would look like 16, 8, 4, 2, 1. And the number of steps is the number of commas in the string. The steps are basically between values. So def hailstone value int returns string. And then inside, what does our if statement look like? Pause for a moment and try to figure out at least part of it. How do we check for the base case? Pause now. What do you think? We know that our base case is when we've reached 1. So something like, I'm going to comment base case if value equals 1. And then the else is going to be our recursive case. We have not reached 1. So in the recursive case, we reduce the problem and call the function again. So we'll write an else for the recursive case, and let's comment that recursive cases, because there are actually 2 recursive cases, right? There's the process we follow for an even value and the process we follow for an odd value. Let's write just that code. Remember how we test for an even number? We talked about it before. If test for an even number, I'm going to give you a chance to remember it. And then if it's even, remember we divide by 2. So value divided by 2. And if it's odd, we multiply the value by 3 and add 1. So value times 3 plus 1. Now, but we're going to calculate the new values, but what do we do with the new values? So you have a bit to think about here. And I did already give clues, and we did already talk about how to test for even or odd. Pause the video and see how much you can fill in here from our prior discussion and your own brain power. While you're doing that, I'm going to add some comments. Pause now. Okay, how much did you get filled in? Remember, we use mod to check for even or odd. Hey, it rhymes. Maybe that can help you remember if you get stuck. Else, if value mod 2 is equal to 0. It's a recursive case, so we need to invoke our recursive function. It's even in the language of the problem description. Proceed with the result. So we're going to call hailstone with the new value. So hailstone, and we'll pass in value flooring division 2. And else, because it's the other recursive case, we'll call hailstone with the value times 3 plus 1. Okay, I think we're making some great progress here. We've identified and tested for our base case, and we figured out what we're passing into the function for both of our recursive cases. But the recursive function has to produce a result, and we don't have any code to do that. And I think that's one of the trickiest parts of writing a recursive function, is picturing and figuring out how those recursive calls build up a result. If we start by thinking about the base case is when we've reached 1. We want that at the end of our string that we're creating. And the string we're creating, and this is the part that's maybe a little weird and hard to get used to, is being created when we return from each function call. So when we return from that base case call, that's when it's all over. We're done. We're not going to call the function again. We're going to just now return from every single call. So when we return that 1, we want to append it to the end of the string that we're going to continue to build as we return from calls. So I'm going to draw what's probably going to be a terrible picture here, but hopefully it will help. I'm going to draw a representation of the call stack. So we call our function, and a frame is placed on the call stack. Let's start with 8 so we don't do this for too long. And we go into our code, and it's not the base case, but it is the first recursive case, and we call again with 8 divided by 2, or 4. So we put another frame on the call stack for this next invocation of our function. And it's not the base case, it's our first recursive call, so we call again with 2. I'll put another frame on the call stack, and that's not our base case, but it's our first recursive case, so we call again with 1. What am I going to do? That's right, another frame on the call stack. Okay, but this is our base case. Here's where we're going to start building the result. So we should return that 1. We're returning it to where we called this function, and that's the last frame on the call stack. So this frame with 2. And it should get appended to 2 in a string. So something like 2, 1. Now, all of that should get returned to the previous frame and get appended to the 4. Something like 4, and then 2, 1. And then that all gets returned and should get appended to the 8. So when I call this thing, I want to append whatever it returns, the 1, or the 2, 1, or the 4, 2, 1, or whatever it is, to my current value. So str value plus comma, and then my call, hailstone value divided by 2, or hailstone times 3 plus 1, converted to a string. Please pause the video and walk through the example again, but now with the code, and confirm that it is or is not going to construct a result string like I described. Pause now. What do you think? Let's try running it. I'll just invoke it and pass in 16. And we get the correct result. Let's try 9. Test out some calls to the other recursive case. Again, the correct result. Awesome. So I'm going to leave it as an exercise to you to write some code to obtain a value from the user and then display both the sequence and the number of steps. I'm going to give you a hint with the number of steps. It's the number of commas, and Python strings have a count method which allows you to count the number of occurrences of a substring. There are other ways you could do that as well. You could split the string on the commas and then take the length of the resulting list -1, but I think count is probably faster. When I upload the code, I'll upload the full version. So that's it. And I know it's not easy to get in the habit of thinking recursively, but hopefully with practice it will become second nature. You can practice writing parts of this in the exercises in the description. You should then try to rewrite this completely from scratch, and of course, write that user interface so you can find the hailstone sequence for any number you want. When you're done, maybe try some of the problems in the back of the recursion chapter of the text. Have fun with it.